Now, this is my lecture number 20.3. In this, I will cover quantization process. Now, this is related to A to D conversion, where three sub processes are involved. That is sampling and quantization and coding. Now, quantization. This word has come from quantity, quantization. So, if my processor is working between 0 and 5 volts, most of the circuits in digital technology works between 0 and 5 volt. So suppose my circuit is working between 0 and 5 volts. Let us say this is the graph for this is 0, and let us say this is maximum value of 5 volt, in which my signal is varying, and this is input to this, which is to be converted into digital equivalent number. Now, let us say I am using 8-bit processor. Now, if I use 8-bit processor, so I will have 256 levels, that is 2 raised to n or 2 raised to 8. This comes to 256. That means here between 0 and 5 volts, I will have a 256 levels. So if I draw 256 levels this way, so one difference between one level, that is LSB, or smallest possible reading, that means 0 and 5 volts are divided into 256 levels. So lowest level, or between 0 and first level, this LSB will be equal to 0.019532125 volts. So that way next level will be 0.01 plus 0.01, and that way this will go on increasing. Ultimately this will reach to 5 volts after adding 256 times. Now let us say I have these levels, 256 levels in this, and I am let us say at particular T1 I take sample. Now T1 sample comes roughly here. Now just notice here, this level is neither this nor this. That means this at T1 level of my signal is in between two levels, not here, not here. So here this condition, now I have this condition. Let us say this is 2.1051 and this is 2.095, something like that. Let us assume this way. So this signal is neither this nor this, so I have to round off this. So circuit will round off to next level, that is this level. That means this much error is added in the circuit. In quantization process, some error will creep in the system. Because of this, you may have 256 levels, but it is very much possible that when I take sample to note down what was voltage at T1, and if that at that instant this that point falls between two levels, so this is known as a quantization error. So that way at so many this works on a real time base. At particular time what was level, so we take levels of the signal at different time intervals, and we note down these levels in memory. And if those levels are called back, and if I those levels I mark here on this graph, so I will get the almost original curve, but not exactly. This will be very similar to this or very near to this, but not exactly the what was signal before, because some error, quantization error takes place in this. So this process of quantization is this: whatever is my range and whatever is level of my processor, you may have 7-bit processor or a 4-bit processor. So 4-bit, you will have a 2 raised to n or 2 raised to 4 or 16 levels will be there, and if 7-bit processor, you will have 128 levels. So these levels will be 128, but it is possible that when we take sample and signal may fall in between, so some this is rounded off, so some error will be added. So that is why in quantization process, when we take voltage value of signal at different instant of time, some quantization error will creep in the system. That is why when we convert a to D and back from D to A, some error will be there. Now of course that is a different thing, that that error will be very small. Here error will be something like this. This is error, this is I can say this is almost 0.01 volt. So that is why physically it is very difficult to differentiate between this signal and this, but technically this is little different from this. And this level of error is tolerable in our day-to-day course.